Good afternoon, viewers. Welcome to Prep Station, UTME Physics 2025. All right, so this session I will be taking you on the first topic for today, and that is measurement and unit. Measurement and units. And we want to consider the following, just few topics under, subtopics under this. So we have, first we'll be looking at what is measurement. And we'll be looking at fundamental quantities and unit. And we'll be looking at derived quantities and unit. And then we'll look at dimension analysis. Then finally, reading accuracies of few instruments. All right, so we are looking at the first subtopic here, which is measurement. I said it's a system of design to measure the height, weight, capacity, or even the amount of certain objects, okay? Measurement is a process. That means you cannot just guess. It's a process because it involves using the device, the measuring instrument, practically to get the dimension of the object you want to measure. Now, to understand measurement, then we also need to consider what measurement really consists of. Okay, so to talk about measurement, you consider two aspects. Number one is the quantity, and then number two is the unit. So you can't really talk about measurement without considering these two. And so under quantity and unit, we have two types of quantity and unit. The first one is called fundamental quantities, while the second is called derived quantities and units. So what you have on the screen right now is the first type of measurement, which is fundamental quantities. Now, how do you define this? These are physical quantities that cannot be expressed in terms of any other physical quantities. In other words, they are the basis. Okay, you cannot derive them. They are independent. They are standard value. You can't derive them. They are just basic. Okay, so I'm going to be showing you the examples, and there are how many in number? 1, 2, 3, 4, 5, 6, 7. There are 7 in number. So this is the standard fundamental quantities in science. So anywhere you go all over the world, these are the basic quantities. So we have the LMT. These three are the first standard. LMT means length, mass, time. Then we have electric current, temperature, amount of substance, then luminous intensity. So these 6 right here on the board, 7 these 7 right here on the board are the basic fundamental quantities. And these are their units. So the unit of length is meters, even though we have other units like kilogram, like kilometer, we have kilometer, we have centimeter, we have millimeters, but you just have to know that the SI unit, what I mean by SI unit, System International, the agreed unit is meters. And then for mass, you have kilogram, just like we have grams, tons, and all of that, but the agreed SI unit is kilogram. Then we have seconds for time. Of course, time, you know, we have the hours, we have minutes, we have seconds, but the agreed unit for time is seconds. Then current is amperes. Temperature is Kelvin. Of course, you know, we have about 3 units also used for temperature. We have what is called the Celsius, the degree Celsius. We have what is called the degree Fahrenheit, and then we have Kelvin. So out of these 3, Kelvin is the SI unit, the accepted unit for fundamental quantities. Then we have amount of substance. Of course, you see more of these in chemistry. When you want to determine the concentration of acid, concentration of base, and all of that, then you look at the moles, okay? Then we have the luminous intensity. The unit is candela. So what I have here are the abbreviation for the unit. So for meters, you have lowercase m, not uppercase. Take note of that. Kilogram, you have lowercase k and then g. Seconds, you have s. Ammeter A, kelvins K. Mole is still mole, then candela C, D. Remember, I told you we have two types of quantities and units. Number one is fundamental, the other one is derived. So I've just finished explaining fundamental quantities. So let's go to derived. Now, what are derived quantities? As the name implies, they are derived. They are not independent. They are dependent on what? On the fundamental quantities. So you can't get them without looking at the fundamental quantities. So they are derived by the arithmetic operation of the fundamental quantities. Either you add, subtract, divide, or multiply. Okay, so these are physical quantities that are a combination of the fundamental quantities. Take note of that. There are many definitions for this, but this is simple enough to understand. These are physical quantities that are what? A combination. This combination here signify what? It signifies the arithmetic operation I mentioned. Either you multiply, either you divide, add, or subtract. So the arithmetic operation of the fundamental quantities will give rise to what? Derived quantities. I want to believe you got that. Now let's look at it. There are many, but I just brought up few here. The first one is speed. Unlike fundamental quantity where I went straight ahead to give you the, what is it called now? The unit. This one is different, totally different. As you can see, we have derivation here. Look at it now. Speed. The derivation for speed of velocity is displacement over time. Can you see that now? Now, this is an arithmetic operation. Displacement divided by time. So this is the derivation for speed. And of course, you can easily get the units by simply looking at what is happening here. And what is that? Displacement represents length. The unit of length is meter over. Time represents, the unit for time is second, and so you have this. So if I represent this in indices form, then you have it as ms raised to power minus 1. So as you can see, it is derived from where? The fundamental quantities. Then we have force. Now the derivation for force is mass times acceleration. Mass times acceleration. So mass times acceleration. So what would that be? Okay, something is missing here. Now the unit for mass is kilogram. Follow me. The unit for mass is kilogram. So if you multiply this by acceleration, acceleration is meters per second squared. So that means the unit for this will be kilogram meters per second. So let me add the kilogram here. So this is the complete unit for force. Then density is mass per volume. Okay, so what is the unit of mass? Of course, that is kilogram, then over. What's the unit of volume? That is meter cube. So if you represent this in indices form, you have it as kilogram meters per second. All right, so you have volume. So and all of this. So any quantity apart from the 7 I mentioned before. What are those 7? Let's go over it again. You have the length, you have the mass, you have time, you have temperature, you have current, you have candela, and then you have mole. How many? 1, 2, 3, 4, 5, 6, 7. So any other quantity apart from these 7 I've written here is categorized under what? Derived quantity. And they cannot be gotten without what? Arithmetic derivation of the whole of this. I hope you got that. So let's move forward to something else. Okay, so it continues. I still have, okay, this dimension analysis now. So what is dimensional analysis? It's the analysis of relationships between different physical quantities by identifying their what? Base quantity. Take note of this. Identifying the base quantity. This, the base quantity. And in this case, I will just want you to depend on the three base quantity. Remember, L, M, T. L for length, M for mass, T for time. So if you can just remember these three, you will be able to show the dimension analysis of any quantity. How? Let me show you. For example, we have speed. The derivation for speed is displacement over time. No doubt about that. And then the unit is what? Meters per second. All you need to do, follow the unit to arrive at the dimension. I'll say that again. Follow the unit to arrive at the dimension. Okay? All you need to do, follow the unit and then represent them in terms of symbols. What do I mean? For example, length is L. So use uppercase L. Mass is M. Of course, time is T. Now let's go with the unit. This is the unit for speed, meters per second. So ask yourself, M represents what? M is the unit for length. And what is the symbol for length? L. So this is the L. Now, second. Second is the unit for time. And what is the symbol for time? T. This is the T. And then put back the -1. As simple as that. You don't need to stress yourself. Get the derivation. Put them back into the base quantity LMT. You are done. Let me do one more. For example, let me jump to density. Density is kilogram per meter cube. So all you need to do, find out the quantity that represents this unit. Now, kilogram is for mass. What is the first letter for mass? M. This is the M. Now, meter is the unit for length. What is the first letter for length? L. This is the L. I believe that is very simple. Very simple. If you just follow my method. Now we have energy. Energy simply means force times distance. Force times distance. Of course, if you play with that using the derivation, you have kilogram meter squared per second squared. I want to believe you know how we arrive at this. Kilogram meter squared per second squared. Just follow the unit gradually. Now, how do we represent this in dimension? I told you, follow the base quantity LMT. L for length, M for mass, T for time. Okay? So come over here. kg represent kilogram, right? Now, what is the first letter for kilogram? What is the kilogram is the unit for mass. What is the first letter for mass? M. This is the M. Can you see that now? Here we have meter. Meter is the unit for length. What is the first letter for length? L. Look at the L. I believe this is very simple. Very simple. Now, S is the unit for time. Okay? S is the unit for time. What is the first letter for time? T. Look at it. So all you need to do, just get the unit and then transform the unit to the first letter of the quantity. That is all you need to do about dimension analysis. I believe that is clear. All right, let's move forward. Let's see other things that we have. Okay, dimension analysis, I've explained this. Now let's go to reading accuracy quickly. Now, reading accuracy is the closeness of the measured value to a standard or true value, the closeness. Now, every measuring instrument have, some percentage or degree of error. Of course, we have different types of error, systematic error, erratic error, random error, statistical error, and all of that. But what we are looking at here is the error of the reading instrument. So every reading instrument have a little amount of, degree of error. And so how do you know the reading accuracy of any instrument? Please pay attention. Now, to do that, you need to find out what is the smallest possible value that instrument can measure. The smallest possible value, depending on what? The calibration of that instrument. For example, let's look at meter rule. Of course, you know what a meter rule is. Meter rule simply means ruler. Meter rule simply means ruler. Do you remember that now? Most people call it ruler. And what is ruler? Is simply, sometimes it can be made of wood, plastic, where you have this first zero, you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 1. You have 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. I want to believe you have seen something like this before. Now, meter rule is calibrated in what? In millimeters and centimeters. And of course, you know, by metric conversion, 10 millimeters will be equal to 1 centimeter. Hope you remember that. So on the meter rule, each of these lines represents millimeters. So where you have 10 lines, it represents 10 millimeters. That is why I have here 0 and I have here 1. What does that mean? If you count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is equal to 10 millimeters, that will give you 1 centimeter. If you continue to count again, another 10, you have 2 centimeters. If you count another 10, you have 3 centimeters. So what are we saying? The possible or the smallest value that this meter rule can measure is what? 1 millimeter. Let me write it here. Is what? 1 millimeter. Look at it. So anything in between these lines will be a bit difficult to determine the value, okay? So the smallest value that this can measure is 1 millimeter. Now let's convert this to centimeter. How many millimeters make 1 centimeter? It's just 10. I told you before now. So let's do the conversion. If 10 millimeters is 1 centimeter, then 1 millimeter will be equal to what? All you need to do, divide by 10. So if you divide 1 by 10, that will give you 0.1 centimeter. So ladies and gentlemen, that means the reading accuracy of meter rule is what? Plus or minus 0.1 centimeter. So that is how we got this value. 0 plus or minus 0.1 centimeter. That means for every measurement from the meter rule, it's either you have an addition of 0.1 centimeter or a decrease of 0.1 centimeter. So that is the reading accuracy, and I've just told you how I got this. How? By checking what is the smallest value that can be measured by what? A meter rule. Okay? So the reading accuracy of meter rule is 0.1 centimeter. And then the reading accuracy of vernier caliper is 0.01 centimeter. So what that means is that vernier caliper can measure a value smaller than the meter rule. All right, so let's go for a short break. I will be back.